Dear students, welcome to our class on computation of evapotranspiration basics 3. Okay, so in the basics 1 we try to understand what is Bland and Cadell method, what is modified Bland and Cadell method, what is Penman equation, what is the modified Penman equation in the first of the basics of computation of evapotranspiration. This is the basics one actually. I am not saying this is advanced. Second, in the second basics of class, we try to understand what is the energy balance method, what is the buoyancy ratio, what is the combination approach by Penman. Okay, so combination approach was used by Penman with two first radiation component, then first radiation components, and the second one is the aerodynamic component. Now, what is aerodynamic component? In detail, we try to understand in this class. Computation of evapotranspiration basics 3. Okay, now see, I always followed this book Climate and Vegetation by Zhenhu Chang. It was dedicated to Zhenhu Chang dedicated this book to his father, who is a geographer, wonderful. Of course, he is a not only geographer, along with Thornthwaite and all these people. He had classified the climates and everything. So then again, another source of information for the aerodynamic approach is this is the wind rock. Basic micrometeorology and instrumentation for this was prepared for the Windrock International by many of my colleagues whom I met in different laboratories across. So across the globe, I can say few of them are still working even today. So they are working. They have occupied highest positions in the, of course, Asia and several places. As a matter of principle, I never talk about the names. I never talk about the names of the scientists or groups with whom I worked, or not to give any priority to someone and else, and also to the companies with whose instruments I have worked throughout my life of approximately 40 years. No, never will I promote as a matter of principle. I am the professor. I should be true to professor's characters of maintain the highest level of discipline, character, piousness, sacredness of the student to maintain. Now, see, from this book also I have taken what is the aerodynamics. See, first I always tell my students, aerodynamics first class for the basics. What is that? Aerodynamics is an object, whatever the object, an object which is in the air. Starting from a kite to an aeroplane to our own crops. Crop lives in two environments, that is the soil environment and the air environment. So aerodynamics is very, very important because the crop is in its aerial parts. So any object which is in the air, it faces the dynamics of the air. That's what we call it as the aerodynamics. When it is in the thermal environment, when I am explaining thermodynamics. When it is in the solar radiation dynamics. So what is aerodynamics? Simply an object, the study of an object behavior with reference to air when it is immersed in the air. So from there I start any class of my students in the basics. Again, basics 3 only. Now here I would like to tell some important things. Here what is it? The basic fundamental thing is that transport of water vapor away from surface is a function of transport of water. Transport of water away from a surface of water is a function of two things. What are those two things? Here, please see here. See, first one is the humidity gradient. What is the vapor pressure at the surface? Humidity gradient at two heights and wind speed across the surface. Airflow, wherein its horizontal motion is known as wind. Wind speed across the surface. So evaporation, this is the evaporation. Evaporation is a function of transport of water vapor away from the water surface. Is a function of humidity gradient and wind speed across. So net radiation is falling, wind movement is there, wherein its horizontal motion is there, evaporation is going on. This is the aerodynamic method. This is the basis for aerodynamic method that was used by Dalton way back in 1800. So what he said, see, in the very thin layer next to the evaporating surface, I'll take this. A very thin layer next to the evaporating surface, diffusion is entirely molecular. That's why I request you, please subscribe to my channel, Agrometeorology, Farmers and Rural Development. There, in the wind, I had explained to you what is the diffusion, what are the gas laws. Okay, everything I had explained. That's why please subscribe. Now, if the airflow were laminar, again I request you, please subscribe to my channel, Agromet, Farmers and Road. There I told what is the laminar flow, how a boundary layer develops, how a turbulent layer develops. Of course, I am not saying that I have completed advances. We are in the basics. Up to that level I have given. Please subscribe and read that. Now, what is it? If the airflow were laminar, if the airflow, what is laminar? I am not going to tell again. I have explained to you several times. Now, the evaporation from a saturated surface, this is a saturated surface, would be determined entirely by the molecular diffusivity. Molecular diffusivity is the only thing when laminar flow is there. If laminar flow is not there, stable, unstable, neutral, I had explained. Please go to those videos, then please see it there. Now, however, the unevenness of the surface differential heating lead to the turbulent motion. Please note that unevenness of surface. Two things I told. What are two things? Zero plane displacement D. Roughness parameter Z0. Okay, roughness. Very daily life I will tell. If you take a cup in a saucer, okay, when wind is blowing, fan wind is blowing or otherwise, okay, what is zero plane displacement D? Zero plane displacement D is equal to, by virtue of its obstacle. So cup obstacle, okay, that is the zero plane displacement D. What is the reference parameter? Reference parameter Z0. The surface, the unit surface. So this is the surface of the water. The way in which when you take the tea or coffee in a cup, the surface. What is the surface? What is substrate? Otherwise, I call it as a substrate in my classes. Substrate or surface. Surface resistance uneven. So that's why, however, the unevenness of the surface, okay, differential heating lead to the turbulent motion. Turbulent motion is the basis for four. What are those four? I will tell you later on. Now, above the laminar sublayer in the turbulent diffusivity exceeds the molecular diffusivity. Please note that laminar flow. Okay. Ordinary molecular diffusivity. Very simple, adjacent to the flow, adjacent to the surface of water which is fully saturated. Just above the turbulent transfer. Turbulent transfer is the basis for aerodynamics. Now, you see, at a height of 1 meter, the turbulent diffusivity, not molecular diffusivity. Molecular diffusivity at the just surface of the water. Okay, saturated. Even saturated soil also, molecular diffusivity will be there. What is the turbulent diffusivity at a height of 1 meter? The turbulent diffusivity may be, just hold your breath. The turbulent diffusivity may be, this bit will come, 5,000 times more than the molecular diffusivity. Just from this surface, 1 meter above, you will find 5,000 times of diffusivity in the turbulent. Okay, this is why I tell all my students every time in a class, if you take an iron rod, presume that this is an iron rod, it is heated to say 200 degrees centigrade. 1 meter away, what is happening? Here it is 200. 1 meter away, just imagine and then tell me whenever I put a question. 2 centimeters, 20 centimeters, 50, 1 meter. Let us take 100 centimeters. How much heat will be there? Though that is what I always give to my students. Now, so what is the Dalton equation? I will tell. Simple, very simple Dalton equation, straightforward equation, which he proposed in the year 1800 is the E is equal. E is water, evaporation from a free water surface. E is equal to simplest thing, Es minus E, function of wind. Es minus E, where Es is the vapor pressure evaporating surface, E is the vapor pressure at the some height above the surface. It is a function of the horizontal wind velocity. Once again I will tell, E0, evaporation from a free water surface is equal to Es minus E, function of wind, multiplied by function of wind, times or whatever, right? Es, what is Es? Vapor pressure at evaporating surface. That's why Penman found that in the year 1948, 1952, his works, Penman found that ES, vapor pressure at the evaporating surface, is very difficult to measure. That's why he had gone for combination approach. Both energy balance and aerodynamic approach he had gone there. That's what I told. So ES is vapor pressure at the evaporating surface. E, or small e, is equal to vapor pressure at a particular height is a function. We have to multiply with the function. This is the Dalton equation. Now here, principle of similarity. See here, some basics. That's why I request you please subscribe to my channel Agromet Farmers and Rural Development. There I told for any fluxes of or gradient of fluxes, flux movement. There are basically 4 flux movements. Number 1, momentum. What is momentum? Basic physics. Mass into velocity is momentum, that is the wind. Second one is that's what we call the Km. In different books, different denotions are there. We finally Agromet should make Km, K small m. Okay, what is it? Moment of flux. Second one is vapor flux, water vapor flux. Water vapor flux. What is water vapor flux? You tell me. So surface and certain height, very high molecular diffusivity. Turbulent diffusivity, very high turbulent diffusivity. So first one is the molecular momentum. Second one is the mass, we call it as, okay. Otherwise, okay, or we call it as the vapor. Third one is the heat fluxes. Net radiation is equal to ground heat flux plus radiant heat flux plus sensible heat flux. That's what heat flux. Okay, KH. The fourth one is the, for we agrometeorologists, what is very important? Very important is our crop. Carbon dioxide is reduced to carbohydrates in the photosynthesis. Kc. Okay. Similarity. What is the similarity principle? All these fluxes of momentum, fluxes of water vapor, fluxes of heat flux, and finally carbon dioxide. There are so many other fluxes. We are now interested. We, the agrometeorologists, are interested in only these 4. These fluxes. What happens to these fluxes? When we presume that all the fluxes are equal. That is the principle of similarity, which is really possible. Fluxes are simple. Then we can derive. If we know one parameter or measure other things, okay, one flux, we can calculate other fluxes. Why we should do? Because now I come to this equation. First equation of by using the aerodynamics. Thornton-Holtzman equation 1939. As I said, always I use Climate and Agriculture by Jen Hucha, which he dedicated to his father in the page number, okay, 164, 65, 66. So there, okay, the after the energy balance, okay, he had gone for aerodynamics in the 157 aerodynamic approach. He had given, first time he had given a wonderful equation developed by Thornton-Holtzman equation. Simple, very simple. Please remember that. Okay, when I come to covariance, Eddy I will tell. Now, just simply equation E is equal density of the air. Okay, Vancouver constant Q1, Q2, U2, U1 divided by log n Z2, Z1. What are these things? Now, I will tell after telling. In the year 1950, he used D. Our Pascal 1950, 1939, 1950. He used D. What is D? Zero plane displacement he used. So what are these terms? Again I will tell. Density of air, Vancouver constant, Q1 minus Q2, U2 minus U1, log n Z2 by Z1. He had modified it. Who? Pascal modified 1950 after 11 years. Just he had taken zero plane displacement, same equation. So what are these things? Q1, Q2, Q3, okay, Q1, Q2. What are these things? These things are U1, U2. Please note that aerodynamics for aviation aircraft, aerodynamics for agriculture, aerodynamics for instrumentation, everything is same. Wind is always used by U. That's it. U2 minus U1. Q. Of course, in some books you will find Q. What is Q? U1, U2, Q1, Q2. These are the wind speeds and specific humidities. Wind speed, U. Specific humidities, Z2, Z1 are heights. That's it. Okay. D is zero plane. Once again, this is the basics of 3 only. We are not going for calculation. Actual computation, I assure you we do it. Now, E is equal to density of air, Vancouver constant, Q1, Q2. Okay, what is Q1, Q2? Humidity, wind speed, Z2, Z1 heights difference. So E same plus zero plane displacement. These 2 equations are developed by Thornton-Holtzman. Now, after telling what is the This is the aerodynamic method. Now I would like to explain to you first covariance, then eddy covariance. Again I am telling you this is the basic three only. What is eddy covariance? First through a diagram I would like to explain, then I will give you simple. What is the eddy covariance? Simple, simple and simple, very simple. F for eddy covariance is equal to density, okay, these two, W and X, mean. This is the mean, okay, at instant, okay, for instant we give dots, we give like this, prime, we give primes for this. Now, F is equal to rho Wx. What are these things? This is the W is the wind, air velocity, upward or, see, this is the thing. If you take a crop, okay, so density of air, which is the W, air velocity upward or down, kg of air meter cube. What is this one? This is the mean. This is the mean. What is the average vertical flux of entity? What is the entity? There are four entities: momentum, mass. Tell me, momentum, mass, heat flux, and carbon dioxide. Average vertical flux of any entity. Now, what is this one? What is the prime? Mean of fluctuation entity. Mean of fluctuation entity. So what is mean of fluctuation? Grams per kg of air. Grams per kg of. Now I will tell. So after giving this small little one more minute please listen. So why eddy covariance? Why we are going for that is that okay, eddy covariance. Okay. Otherwise we also call it eddy correlation technique. What is eddy? First aerodynamic method we try to understand. Who have Thornthwaite and Boltzmann, okay, Thornthwaite and Holtzmann. Now it was improved by Pascal. Now eddy covariance technique. To overcome the limitations of Thornthwaite and Holtzmann, and to some extent, okay, later by other scientists, Swinbank in 1951 was the first to attempt a direct measurement by eddy correlation technique. Wonderful technique he developed. Why it is wonderful, I tell you after half minute. This method is based on the assumption that the vertical eddy flux, if it is a crop, this is a crop, this is a crop, this is in the air. Four fluxes are there. Fourth time I am telling. First flux is momentum, second mass, third one is heat, fourth one is the CO2 fluxes. Now, this method is based on the assumption that the vertical eddy flux can be determined, any of these vertical flux, okay, can be determined by simultaneous measurement of the upward eddy velocity and the fluctuation in vapor pressure. Upward eddy velocity, okay, and okay, vapor pressure. Bar, what is the bar here? Again, another equation. What is the bar here? A bar over the quantity denotes mean value in time. Okay, prime. This is the prime. Again, behind this, I am showing it to you. If you are just the same thing I wrote here. Okay, eddy covariance. Okay, this one. Okay, let us see this one only. Let us not go for another confusion word. Okay, so here, eddy covariance is equal to, okay, these are the primes. What are these? I had explained to you. Average of the vertical flux. These two. Okay. First, this one is the density of air. This one is the air velocity. Kg of air per cube meter. Okay. This one is the mean of the fluctuation entity of in grams per kg of air. Okay. This is what is the eddy correlation or eddy covariance. Of course, simple instruments are enough for this. Simple instruments are for at the field level for our practical class. What are those? What we need here? Air, okay, fluctuations in the jet to at a particular height. Difference between two heights of mid velocity. What is the fluctuation of any entity? What is the entity? Momentum, mass, heat, carbon dioxide. Any entity you take, relevant instrument you take, psychrometer. Or electronic devices, nowadays electronic devices have come. Any instrument will measure 2 or 3 or more also. So those instruments also have come. Simple eddy covariance is the same, follows aerodynamic. This is a simplified version where F is equal to air density. These two factors I told several times. Now, so what is needed simply for eddy covariance is the thermometer reading, okay, to measure air velocity at two different hygrometer to measure the Q values. That much is there. Simple equation is there. Now, see eddy covariance are, okay, nowadays highly sophisticated aircraft. They carry it. Eddy, I was fortunate. in any advanced laboratories of agriculture, this is the basics of advanced laboratories of agrometeorology. Eddy covariance instruments, towers are there, basic towers are there, laminar flow, boundary layer development, free air, from there, average fluxes. Just hold your breath, I tell you. The 1/100th of a second, you will get the wind velocity at two different, 1/100th of a second. So that's why when aircrafts are landing, when aircrafts are taking, when these car races of Formula 1, something like that are going on. So there the drag force, the stress, Reynolds number. Please, that's why I request you, please subscribe to my channel. Agromet, farmers and road development. There Reynolds analogy I told. So stress, drag force, all act on aircraft or a racing car or a car going against the wind, okay, or cycle against the wind, a kite flying. All these things were taken care of with the eddy covariance, towers. Eddy covariance are there nowadays in the aircraft, advanced aircraft in the year 2021. Steamers, okay, when they are traveling from one continent to other continent in different fluctuation of weather. So why I am telling is, for we the agrometeorologists, we should know aerodynamic method. These are the basics of eddy covariance also. Why? We grow intercrops. A tall crop of red gram grown in, when we grow a short crop of, say, groundnut. A tall crop of java, we grow for some green gram. At what distance, row to row, what? Whether it is 4:1 or 5:1, 6:1. Eddy covariance helps us a lot. So, in determining from there, if we start mango orchards, coconut orchard, it is my experience. What an innovation I developed for uprooting of coconut plantations of 30, 35, 40 years old, which are really giving a very high economic yield, are just thrown away in 1 or 2 hours of high speed winds when cyclone crosses. Z0 plus D at the same height. There my technique says that you put up to Z0 plus D height, any weight, nothing would go wrong. So like that, innumerable advantages are covariance, eddy covariance. So this is what I would like to say. So far we try to understand blind indicator method, modified blind indicator method. Penman equation original, modified Penman equation. Second class we try to understand energy balance, Bowman's ratio. Then combination approach of this Penman, that is the aerodynamic term plus before that energy term, okay, radiation plus energy. Now in the class aerodynamic method, aerodynamic covariance. Then we try to understand what are the resistant approaches. Thank you. These are the basics only. Advances we calculate, we actually compute. Thank you very much for your patient hearing. May God bless you.